Hi, good afternoon, everyone. I suggest that we get started with our next session. So my name is Elwyn Davies. I'm at the World Bank, where among other things, I work on the World Development Report on AI, and I'll be moderating the next session, which is on AI and reorganization. Rafaela Sardone in the talk this morning already highlighted that this is very much a key challenge when we talk about the adoption of this wonderful technology. And it's a big challenge, kind of how do we actually get AI embedded in organizations, and what should these organizations look like? So for this session, we're having an exciting lineup of papers. First, we have Chiara Criscuolo, who is with us at the World Bank Group in the Private Markets Research Group, which is closely aligned with the IESE. And she will talk about the diffusion of AI in multinationals. We know that multinationals are often at the frontier, but is that also the case for AI? Then we'll be moving on to a more forward-looking question. Eduard Talamàs, who is an assistant professor at IESE Business School in Barcelona, will share insights on what it means for firms if AI becomes truly transformative. What does this mean for firm structures and investment decisions? And the third paper in today, this afternoon, will focus on what does AI mean for the international outsourcing of services. And we have Maggie Chen with us, who is a professor of economics and international affairs at George Washington University here in DC. And she will present evidence on how online markets for services are adjusting since the arrival of Gen AI. Every paper presentation will be about 15 minutes. We have over 180 attendees, actually, and I think a few of them actually identify themselves as AI agents. So I encourage everyone, human or AI agents, to ask any questions you have in the chat. We will have about 15 minutes towards the end for Q&A. But let's get started. Chiara, over to you.
Thank you. Thank you very much, Elwyn, and it's a pleasure to be here. Let me repeat what other speakers have already said, and big, thank you and compliments and congratulations to Jonathan and team who have organized the conference. And in addition to this, I should say they're also co-authors on the papers, on the paper that I'm going to present now, and I hope you can see my screen. So let me try to make it bigger, which I don't manage with the... Okay, tell me if you can see the full screen now. So I hope you do. So this is, as I said, joint work with Tim and Jonathan, but also with Flavio Calvino from the OECD and Antonio Ughi from the Paris School of Economics. As the title says, first of all, this is work in progress, so comments are very welcome, and be forgiving on the fact that some of the results are very much preliminary. Now, the title also says quite clearly what we are going to look at, which is AI diffusion within multinationals, and I hope I can go quickly on why we believe this is an important contribution to a growing literature. And today we have had the chance from the keynote, but throughout the rest of the day, to really discuss the fact that AI adoption is highly uneven across firms, and diffusion of this technology is also highly uneven across countries. And you mentioned, Elwyn, we don't know, and I'm going to show you that actually MNEs are big players in this AI revolution, as was said before. However, we still do not know very much, and it was nice to see today some, I would say, experimental evidence, but I think we still need to learn a lot on how MNEs actually adopt AI. For example, who are the first plant that get chosen to pilot these AI technologies, and then how these AI technologies diffuse within multinational firms. For example, how much does distance matter? How much similarities across plants matter? Is this diffusion a blanket through all the plants of the multinational, or is there some selection of which plants are going to be adopting these AI technologies? Now, why do I think that this is also an important point is the fact that from evidence from previous waves of digitalization, we know that multinationals are important early adopters and as you said, frontier adopters of these digital technologies. But we also know that they might be important vector of diffusion across countries, and diffusion not only of digital technologies, but as Raffaella very nicely discussed in her keynote, of the complementary HR, management, organizational best practices that can actually help firms get a productivity gain or a stronger productivity benefit from adopting this technology. So you can imagine that this is very important to understand this diffusion dynamics within multinationals is particularly important for development and for potentially justifying policies that tend to attract multinationals. So this is where we start, and with this motivation in mind, we are going to answer two very straightforward questions. Where do MNEs first adopt AI? How does AI then diffuse within multinational corporations? And by trying to answer these two questions, we actually provide some very simple, but I think some very clear slides facts. I'm going to present 4 of them today on MNE's AI adoption and diffusion dynamics. And we start, I think, providing evidence on the potential factors that can explain both first adoption of AI, but also how factors that affect the diffusion of AI within multinationals. So before I start, I thought it was useful to start from anecdotal evidence, sort of an example from a multinational, which I think is a household name for many of us in the conference, Bosch. Probably you know Bosch because, of its fridges and washing machine dishwashers, but actually Bosch is a global technology and services supplier. And as such, it has plants in over 60 countries, 500 affiliates, more than 400,000 employees. So a very large player. And as provider of technology, actually has locations focused on research and advanced engineering across the globe. Now, when you look at the slides, I try to highlight a specific location, which is Renningen. Renningen is actually in southwest Germany, as you see in the slide. And in Renningen, Bosch has what he calls the Bosch Central AI Hub. This is where Bosch sort of experiments and start pilots AI systems and everything that is related to, for example, computer vision, predictive maintenance, zero defect manufacturing. So this is really where things start. And what is so specific about Renningen is located in what is called the Cyber Valley. And the Cyber Valley is the largest and most important AI knowledge hub in Europe, where you have the University of Tübingen, the University of Stuttgart, Max Planck Institute, lots of AI startups and lots of other large firms focused on AI, including Bosch. And so here is where Bosch is really embedded in this strong AI knowledge base. Once it has started experimenting, and we know from the Bosch website and press releases, is that it really wants to improve its capability learning by being close to this AI knowledge. Then in a second step, it actually continues and rolls out this AI system to other subsidiaries in Europe, in Asia, and North America. So you really see that there is a sort of piloting and a rolling out of technologies. And we also know that these subsidiaries where these AI technologies are then diffused are not all of them. They're just some selected plants. So why did I want to tell you this? Because as you will see, this Bosch story is something that we find for our average multinational in the sample that we look at. And the reason is is exactly what we discussed before. They want to be close to knowledge in the first place, and then they can implement it relying on their own knowledge. And I'm going to show you this afterwards. So I'm going to go very quickly here. We use a commercial database, which is now called Spicework. It used to be HeartTanks. Just to say, we have a very large sample, about 30,000 multinational and their establishments, and we have a balanced panel over a 5-year period, 2016 and 2022, for over 30 countries. Now, the interesting thing that I want to highlight here is that we are able to geocode the addresses of the plants that we have in our sample, and therefore we can measure the proximity to what we call AI science. So in a way, we can identify the Renningen in our sample, and we measure this AI science using OpenAlex, which is an open source database. And what we do is we look at the publications, if you want, between 2000 and 2015, so in a pre-sample period, and we identify the institutions, the research institutions that actually have published in AI. And so the measure we are going to use is how many establishments are located within a 50-kilometer radius from a specific plant. I mean, obviously we have lots of different robustness checks. I'm not going to show them today, but just to give you an idea of what we are trying to do. So let me start with what I promised, which is giving you some facts. Elwyn was asking, do we know whether M&Es are actually also at the frontier of AI adoption? And I hope that these slides convinces you that this is the case. So what this slide shows you is the share of firms in different groups. So we have single plant firm, domestic firms, multi-plant domestic firms, and multinationals. And we look at how many of these firms actually are using AI, defined as machine learning, in each year. So what you see, for example, is that in 2016, you already have a significant difference in the share of multinational using AI, almost 5% relative to the other firms. But you also see that the speed at which AI is diffusing within multinational is actually much higher than in the rest of the firms. So the gap between M&Es using AI and domestic firm has actually opened up over the 5-year periods that we look at, with more than so almost 15% of M&Es actually adopting AI at the end of the period. Second, and this is very much in line with the Bosch story, when we look at the adoption of AI within multinational, we see that in more than 90% of multinational firms in our sample, actually this AI adoption is partial and not complete. So it's not, as I said, a blanket use of AI. And so this sort of suggested to us that there might be some piloting going on and some selection of plants that actually are going to be adopting AI within multinational. And in fact, this is exactly what I'm going to show you in this slide. So what we look at is how many, so if I look at the share of subsidiaries, if you want, adopting AI within multinational in its first year of adoption, we see that a third, sort of almost 35%, only see 20% of plants adopting AI, and similarly, we only see just about 15% having more than 80% of their plant adopting AI. So you see that this is not sort of a done deal, but there is, again, a slow process of diffusion even within the multinational. And let me show you this more clearly in these slides. So let me go slowly because I think it's important to understand what we are showing here is, if you want, two ways of looking at a similar story. So when we look at panel A, what we are trying to explain is how many multinationals actually see more than the first adopter of AI, other other plants adopting AI. And what you see is, for example, after the first year of first adoption, less than 15% of M&E firms actually have more than one subsidiary having adopted AI. And what you see is that after 6 years, this number goes up just to 40%. So again, very slow adoption, very partial. And you get a similar story when you look at the fact that even after 6 years of adoption, only 40% of plants on average within multinationals actually do see adoption of AI. So again, very partial adoption within multinationals. So it's important to understand which firms these are. Now, let me go to the last part of the presentation, which is just trying to understand how much this proximity to AI science and AI knowledge actually helps first adoption. And what we show you, and let me, for brevity, just focus on the column 4. What we see is that proximity to AI science is actually an important factor in predicting AI first adoption in multinational, but we also see that internal complementary technologies such as use of ERP and cloud in first adopter is very important and is a strong predictor of AI adoption, while size and age, once we control for this complementary technology, do not matter. What is very important, and I think this is why I'm going to say that M&Es can be a bridge to frontier technology, is that this proximity to AI science actually does not matter for the diffusion of AI technology within multinational, but only for this first adoption. And in fact, let me give you some very preliminary result. We find that once we look at diffusion, what really seems to matter is the fact that there is complementary technology in place, in particular cloud, and that we also find evidence is that there is a piloting. We see that plants that use the same vendors are the ones that are more likely to adopt technology in the second place. So I don't know if I still have 1 second to conclude. What I wanted to show you was that AI is first piloted in very few establishments and only partially diffused to the rest of the multinational, and that this early adoption is very much a function of proximity to AI knowledge and also to pre-existing complementary technologies being available in these plants, in these subsidiaries. And so, in a way, this is very much multinational adopting these technologies, these frontier technologies close to frontier knowledge. However, this frontier knowledge does not explain, and this does not matter for explaining how AI diffuses to the rest of the M&E company. And so in a way, this helps us maybe better understand how M&E can be bridges for this technology diffusion also to non-frontier location. One final point, you saw it very clearly in the results, the importance of complementary technology. And so this is something that I think has come up also in previous presentation today. So let me stop here and thank you for the attention.
Thank you. Thank you very much, Chiara. Eduard, over to you.
Let me unmute myself first. Beautiful. Okay, thank you so much for having me. I'm really excited to be here. I'm learning a lot from all these previous presentations. And I really want to tell you about this joint work with Enrique Ide and also Ronnie Chatterjee and Daniel Rock. It's about transformative AI and firms. And really the beginning of the whole research agenda that I'm involved in these days is this idea that AI is a fundamentally new automation technology. And this is something that Rafaela has already emphasized this morning. And so she said, this is something that blows my mind. It really blows my mind as well. So I want to tell you again about it. And the reason AI is different from previous automation technologies is not because it tackles cognitive work. We've had plenty of automation technologies before that have tackled cognitive work. The difference about AI is a different one, which is about codifiability. Right? What is this codifiable knowledge versus non-codifiable knowledge? What is the distinction? It turns out to be the key distinction for understanding AI, in my view. And the idea is that codifiable knowledge is things that we can write down in code. We can write down. We can explain what is it that we know, and as a result, it's transferable. And previous automation has only been able. So previous machines until now have only been able to do tasks that we could explain very well, that we could codify. The non-codifiable knowledge, things that some humans know, but it's hard to explain, these things were out of reach of automation. And now AI really it fundamentally breaks this codifiability constraint. This is not new. It's not my point. This has been said by Eric Brynjolfsson and Tom Mitchell almost 10 years ago. Also, author in this beautiful essay that Rafaela also quoted. So this is an observation that it has been out there for a while, but I think with the recent advances in AI, answering the question of what are the economic implications of these is very central, and that's what I'm trying to do with my research. So what I want to do today is really tell you three answers to this question that I've been involved so far, and it's about three different papers. All of them are published, so I'll put them on the chat later. I'll go very briefly, just three stories about what are the highlights of what are the economic implications from different points of view of this idea that now we have a technology that can get to non-codifiable knowledge. Okay? Now, the first answer is based on this paper with Enrique IESE. And what is the point in this paper? The idea is that we have in economics a whole literature making the point that this non-codifiable knowledge is actually a major bottleneck. And actually, Rafaela and others in the audience have contributed to this literature as well. So the first point is to say, look, AI is a technology that can automate this fundamental bottleneck. That should lead to a reorganization. Why is that? Well, first, let's understand why is it such a big bottleneck, this non-codifiable or this tacit knowledge. The idea is that by being non-codifiable or tacit, this knowledge is embodied in individuals. If a human knows something, he or she knows it, but it's very hard to explain. So in order to access that knowledge, we need his or her time, right? So the use of experts' time the use of experts' knowledge is constrained by their time. As a result, the organizations, and an important part of organizations in the knowledge economy is to actually set up structures around experts to make the best possible use of their scarce time. Okay? And this insightful idea of why organizations, or partly why organizations are hierarchical, and really goes a long way in understanding the labor income dynamics in the knowledge economy in the past couple of decades. So our point in this paper is to say, okay, that's true, but now here comes AI that can automate this non-codifiable knowledge. That should lead to a reorganization, because it's automating the bottleneck around which organizations were being structured, right? So in the paper, we take a canonical model in this literature, we introduce AI, and we study the whole reorganization. I'm not going to go into the full detail. Please go to the paper if you're interested. Let me tell you a highlight that we obtained, which is, and it's something that has come up in the morning as well, this idea that the autonomy of AI systems has fundamental distributional consequences. So we can think of an AI system that knows a certain amount, but there's still a question about how much it can do by itself. In a sense, there is this debate about, do we have AI tools that we can access, or do we actually have AI agents that can do work for us? And one thing we're pointing out with this framework is that this has huge implications for labor income inequality. In particular, when we introduce autonomous AI agents in this framework, we find that the most skilled, the most knowledgeable individuals, those who are earning the most, are actually always complemented. Their income goes up. What happens to the lowest skill individuals depends on how good AI is. Unless AI is very good, actually autonomous AI will replace the least knowledgeable individuals, right? So labor income inequality goes up both because the labor income of the top income go up, but also because the labor income of those in the lower part of the distribution goes down, right? So it's huge increase in labor income inequality. We can look at non-autonomous AI, same knowledge, but now it's non-autonomous in the sense that we can access it, we can ask questions, it can help us solve problems, but it cannot actually do the work for us. And that has the opposite effect on labor income inequality. The most knowledgeable individuals don't have a lot of use for this kind of AI because they already know a lot. They don't benefit much, but the least knowledgeable individuals benefit a lot. And as a result, the most knowledgeable individuals lose because they have to now pay more to those who know less. Okay, so that's essentially the story. So here comes, one of the main points of this paper, which is there's a sharp trade-off between efficiency and inequality. Introducing autonomous AI increases output much more than non-autonomous AI, but it also leads to much bigger labor income inequality. Okay? So that's the essence of, or one of the key messages of this paper. Now, in another paper published actually this month in the Journal of Monetary Economics, we take this analysis to international trade and global knowledge work. Okay, this is something that Maggie is going to talk about in a minute. So I think she's going to present empirical evidence. I have no data. I'm just thinking through using this kind of knowledge economy framework to think through the consequences of AI for offshoring. We start in this paper with three stylized facts. The first is that offshoring is increasingly about services and knowledge work. Second, AI can increasingly do this kind of thing. And third is that a lot of the AI needed to do this knowledge work, the inference compute, is actually in advanced economies. It's very concentrated, mostly around the US and China. So what we ask in this paper is, okay, what is the consequences? What are the consequences of this using the framework I've just described? What are the main messages? Well, the first one is sort of similar to what I've said before. Well, AI is a scalable, is a technology that allows us to use non-codified knowledge at scale. That should lead to a reorganization, in particular in this case, a reorganization of international trade. What's going to happen to offshoring? That's an interesting one. There's a lot of debate about and a lot of concern that individuals in developing countries that have been focusing on this offshoring, doing routine work for more advanced economies, that they might be completely wiped out by AI. Well, our analysis suggests that that's not so clear. So if we introduce autonomous AI, whether this increases offshoring or decreases it depends on how good AI is. The idea here is that if AI is very good, actually it will lead to an increase in demand in routine work. Because AI is so good, it's really focusing on problem solving. Now it needs a lot more people doing routine work, and that's what the developing economies are specializing in. And then we go back to this trade-off between autonomy and labor income inequality. We say, okay, if you can do a global restriction on AI autonomy, same story as before. But what becomes interesting is once we start thinking about regional autonomy. And the fact that there's such a divide between compute-rich regions and regions that have don't have a lot of compute for AI, that means that regions that actually don't have a lot of the developing economies that don't have a lot of compute, we analyze, okay, what are the kinds of regulations these regions can do? And they don't have very, very good options to, it turns out, right? So the fact that there is this divide between compute across the different countries implies also very stark differences in the kind of regulation different regions can do. Okay, so that's the second paper I wanted to tell you about. And finally, I want to go to the third paper, which is really using a different kind of framework to think about the implication of AI being able to do non-codified knowledge work. Okay, and this is based on the knowledge view of the firm. In particular on this idea of that has been pushed, particularly by Nonaka in the 90s, about the spiral of knowledge. Let me tell you about this idea, okay? It really, we go back to the same idea as before. There's tacit knowledge. Until now it was human knowledge. That was what we were calling non-codifiable. knowledge. And then there's explicit knowledge, the kinds of things we can codify. Okay. And one fundamental difference between the two is that one is very easy to transfer. The explicit knowledge, the codifiable knowledge, we can write down in code, we can write down in language, in algorithms, and then it's very easy it's very easy to share. It can be transferred across the organization, for example. Human tacit knowledge lives in humans' head. It's very difficult to transfer. Okay, the previous kind of frameworks were all about the idea that given this non-transferability, how do we organize our firm to make the best possible use of this human tacit knowledge? This other framework is all about how do we actually get from human tacit knowledge to explicit knowledge so that the whole organization can actually use this kind of knowledge, okay? So the idea here is the organization is important and it's better than the market because it allows the experts in the firm to actually codify what they know so that everyone can then use this knowledge. So there is this spiral of knowledge that is emphasized about, okay, we need to be creating human tacit knowledge in the organization. We need to be able to codify it so everyone can use it. Then we need everyone to internalize this knowledge so that we can go back and create more human tacit knowledge, okay? So that's the whole idea of the knowledge creating companies. You have to be able to get this spiral of knowledge right. Okay, so that's the framework out there, and we come and say, okay, what about AI? Is it transferable? Is it non-transferable? And actually, it's in between if you think about it, because machine tacit knowledge, the thing that AI knows, is really very opaque to humans. So in that sense, it's non-transferable, but it's very easy to transfer across machines. It's digital weights that you can copy across machines. So now there is this new kind of knowledge, which we call machine tacit knowledge, which is neither transferable, non-transferable, neither transferable nor non-transferable, right? It's transferable across machines, not transferable to humans. And that creates a new constraint, a new challenge for organizations, and which is how do we allow this spiral of knowledge to go from human knowledge to machine knowledge and vice versa, okay? The idea is human and machine knowledge is complementary because they come from different kinds of data. So we want the organization to be building all of these sources of knowledge. How do we do that? Well, there are several steps. Some of them are more obvious than others. We call these the challenge, the human-machine spiral of knowledge. The organizations have this new challenge of incorporating this AI knowledge into the picture. What are the ways to do this? Well, the first is encoding, taking explicit knowledge, things that we've written down, and training AI systems so that the AI systems can get this knowledge in the organization. Also embedding, so taking data from human tacit knowledge and trying to train the machines with it. So that these are sort of all about, okay, taking the knowledge in the organization and bringing it into machine form. But then there's the opposite direction as well. So we need to be able to take this machine tacit knowledge and make it explicit so that humans can understand it, right? So there is this role for the organization to extract the knowledge from the machines so that it becomes explicit knowledge and humans can understand it and build off that. And also assimilation, which is going from machine tacit knowledge to human tacit knowledge, right? So that by interacting with the AI, humans can get tacit knowledge directly from this machine tacit knowledge. So now this famous spiral of knowledge of Nonaka becomes a much more complex spiral, which it's all about trying to keep reinforcing all these different kinds of knowledge. Okay, so I'll conclude. New economic reality, AI allows machines to break fundamental codifiability constraint. In terms of this leads to reorganization in many ways, and I've told you three concrete ways in which this happens. And this new reality brings a new kind of knowledge, machine tacit knowledge. It's codified for machines, not for humans. That makes it a new kind of knowledge that we want to understand. In terms of policy challenges, we've emphasized autonomy. Leads to this trade-off between efficiency and inequality. And in terms of different regions, there is a sharp divide in regulatory options between compute rich and compute poor regions. And in terms of managerial challenges and opportunities, Well, the idea is to try to avoid this efficiency trap of organizations using AI a lot, but not incorporating into their knowledge creating capabilities that can lead to stagnation. And the idea is instead orchestrate this human machine knowledge spiral where humans and machines are continually teaching each other and leading to more innovation. Thank you very much.
Thank you. Thank you very much, Eduard. Maggie, over to you for the next presentation.
Thank you. Thanks very much. Let me get my screen shared. Okay. All right. Okay. Well, thanks very much for having me. This is a great conference, and I'm really happy to have the opportunity to present my work with one of my PhD students, Niham. And I'm particularly delighted to be on this panel. And I think Edward, for example, did a great job giving the theoretical framework of my paper. And of course, I also learned a lot about these other aspects of AI autonomy. So I really appreciate that. So this is a work in progress. We are trying to add to the literature by highlighting the impact of generative AI on cross-border services trade. And I think, by now we all understand that generative AI is hitting and targeting, the workforce of developed countries, especially the high-skill, white-collar workers. And unlike robotization, as we have already been comparing, in today, which replaces physical labor at a localized level, generative AI is performing digital tasks at a global scale. So the question we are trying to answer in this project is, how is this technology going to reshape cross-border services trade? Let's see if I can move this. I don't know if everybody can see the title. Yeah. Okay. So why is it important? Well, in the last decade, many developing countries have relied on digital services exports as a main engine of economic growth, right? If you think about India, Philippines, and quite a few South Asian countries, and Eastern European countries like Poland, and even some African countries in Latin America have been really experiencing this rapid growth in digital services exports. And the question here, though, is, could the services offshoring and exports, once enabled by ICT, now become potentially reversible by AI? Now, so that forms the question we're trying to answer in this project. How does generative AI reshape cross-border outsourcing in digital services? And I don't want to repeat what our panelists and speakers have already been discussing so far, but let's focus on the context of international trade in digital services, right? ICT revolution has lower communication costs, in the last 3 decades, and that enabled global dispersion of work, which, fostered the international outsourcing in not just manufacturing, but also in services. And then robotization came along, which replaced and automates physical tasks, and that reduces the labor cost advantage of a lot of developing countries, leading to reshoring back to the advanced economies. Where does generative AI sit? So generative AI is automating digital tasks, cognitive tasks, and that is that's not bounded by geography. Unlike robotization, which is doing a lot of automation at localized level in developed countries, generative AI potentially can substitute a lot of labor around the world. And that compresses the wage arbitrage, between developed and developing countries. But not only is doing that compression, it also at the same time augmenting the productivity of foreign workers. So the net effect on international outsourcing and international trade can be theoretically ambiguous, and that's why we're trying to tackle this empirically in this project. So how do we answer the question? We try to provide some causal evidence on generative AI's impacts on cross-border task flows by exploiting the setting of cross-border online labor marketplaces. As many of us know, the OOM, the online labor marketplaces, have become an increasingly important global platform for digital services outsourcing, and is covering, growing share of global labor force. And through these platforms, we are able to observe very detailed buyer behavior, worker behavior, and task level transactions in many cases. So for our project, we are going to collect micro-level transaction data across about 2,700 skill areas from January 2022 to December 2024. And we're going to try to gather data from both sides of the market, the buyers as well as the workers, and the transactions that happen in between. And we want to explore not just the time variation, obviously the launch of ChatGPT and the model releases. More importantly, we want to look at the cross-sectional variation across the 2,700 skills. And we have constructed measures of generative AI automation across all the skills in our platform. And this exposure measure is constructed by evaluating AI's own self-assessment of the skill substitutability. And this gives us a perceived capability-based measure that measures how economic agents, including businesses and multinationals themselves, try to assess the capability of AI and update their beliefs in their decisions about outsourcing. So what do we find? At the aggregate level, we find sharp declines in international outsourcing, but that decline is concentrated among the developing countries. And the magnitude is not trivial, right? We're seeing about 34% decline in outsourcing value and 40% in outsourcing value and about 34% in the volume of contracts. Now, what about the buyer side? We are seeing a lot of reorganization, as Edward actually predicted. We're seeing a lot of reorganization. The number of businesses that continue to outsource declines, the number of contracts declines. However, the average contract value actually increases, accompanied by this increase in the budgets allocated to the remaining jobs. And we find AI-related task demand also rises, but not reflected in the pay. On the worker side, we see displacement with some selective adaptations. On the extensive margin, we see fewer workers getting jobs and fewer contracts per worker. However, the average contract value actually increases among the continuing workers. And the workers are also not sitting there absorbing the impact. Some of them actually are transitioning to adjacent and more interactive soft skills. However, we find very limited evidence of AI upskilling at the systematic level. What does all of these mean? We find actually this means concentration of work on the platform, with the top 1% capturing larger share of jobs as well as earnings. I'm going to skip the literature review, but just to say the paper is obviously joining several strands of literature looking at generative AI, online labor marketplaces, as well as automation more broadly. Okay, so let me go into details a little bit about the empirical context. We are looking at online labor marketplaces, and in particular, we are zooming into a leading cross-border OOM that specializes more in the international outsourcing. And on this platform, we observe not just large enterprises, but also many, many small, medium businesses. And one important feature for us is that we know we are looking at transactions across about 2,700 skill areas, spanning the different types of professional services. And as I mentioned, this platform is mainly cross-border, so 91% of transactions are international between countries. And demand concentrated in developed countries, whereas supply mainly comes from developing countries, in particular South Asia. Why this particular platform for studying AI national outsourcing? As I mentioned, we need very granular task. We have very granular task data. We observe high frequency adjustments, which is important for us to observe the responses to generative AI. And we observe both sides of the market, the buyer behavior, buyer decisions, as well as the worker behavior and adjustments. And it's international by design, which gives us a very natural setting for studying cross-border task flows. Now, the data we collect is essentially a client-worker skill transaction microdata. We have worker profile information, client records, as well as detailed project transaction level data. Okay. We observe the types of skills being demanded, being supplied, and not only the volume as well as the pay, the value of the projects, and we also have information about the quality of the work that has been delivered. Okay, a key variable for our analysis is the generative AI exposure. For each skill in our platform, we construct a measure of how substitutable the workers are to generative AI. And we decide to use generative AI ChatGPT in this particular case to have ChatGPT assess its own ability to substitute workers for each skill. And we give the ChatGPT, in the prompt, we provide a task list associated with each skill. And then we ask ChatGPT to evaluate how likely or how well generative AI can perform these tasks associated with a given skill relative to human with minimum human input. We have experimented with different prompts for validation, and we do this type of prompting and data collection 100 times for each skill to reduce stochastic variation. Why this approach other than budget constraints? So this gives us very fine level of measure of exposure for each skill we observe in the marketplace. And it's based on capability rather than actual outcome or actual adoption, because that's what we're trying to measure. And it's capturing perceptions, beliefs, because we believe this reflects how agents, including business executives, actually update their beliefs and make their decisions about outsourcing. And it's scalable. We can do so for all the skills we have available, and we do some validations against existing measures. So here is a list of most exposed skills and a list of least exposed skills. Not surprisingly, the highest exposure is seen for skills like writing, coding, translation, design. A lot of the skills we kind of expect to be highly substitutable. For the least exposed skills, you see a combination of physical skills, including, for example, fashion modeling and obsolete technologies and highly specialized domains. I actually saw firefighting somewhere, and that really alarmed me. But it turns out it is like firefighting consulting services, the fire safety. So these are very specialized domains that are not as easy to substitute. So this is some validation exercise we did against some of the leading indexes in the literature, and we find we have to aggregate our skill measures to occupational level because a lot of these indexes are measured at the occupation level, and we find high correlation, but still we do have variations, some variations. Okay, so this is the spatial world map of exposure to generative AI based on the online workers in our platform. And you can see the developing countries are really some of the highest exposed countries to generative AI because of the specialization of the online workers in these countries. Okay. All right, very quickly, let me go over some of our results. So at the aggregate level, we find the outsourcing value to decline significantly, especially in the most exposed skill areas. At the mean level, we find about 50 to 40% decrease in value as well as in contract numbers. And the extensive margins are actually driving some of these results. The number of buyers continuing to outsource and number of workers continuing to get jobs, both have declined substantially. And this you can see the dynamic effects that the impact of generative AI was initially fairly modest after GPT 3.5, but accelerated after GPT-4 was introduced across the board. Now, if we go into the disaggregated levels, and let's start with the demand side, among the businesses that continue to hire workers on this platform, we find that the volume of contracts decreased significantly. However, the mean value of the contracts actually increased. So this suggests that even though there is less demand in terms of the number of projects, the complexity, the value per contract actually has been rising. This is also seen in the budget offered for these projects. You can see minimum budget, maximum budget, and budget spread have all increased for the businesses that continue to outsource on the platform. And the complexity, if we look at some measures of complexity of the projects, you can see the projects that continue to be outsourced tend to take longer time to finish, have more descriptions in the demands, and the share of AI complementarity work has also increased after the launch of generative AI. Now, on the worker side, very quickly, we find very much a similar evidence. The number of contracts has declined significantly for the workers that continue to get jobs, but the average value of the contracts actually increased by about 40%. Okay. And how do workers deal with that? How do workers respond to such shifts in labor demand? Well, it turns out this is actually echoing some of the existing work. We find the quality of the work has increased primarily for the underperforming workers before ChatGPT, and you can see that monotonic relationship between the improvement in quality and the pre-GPT ratings. Now, in terms of skill compositions, what we find is that the workers actually not on the one hand, they are losing jobs in some of the old skills, so they're dropping the old skills, but on the other hand, they're also acquiring new skills. And in addition to the skill composition changes, the contracts and they continue to get jobs are actually more complex in terms of the number of skills required. So we are seeing this, this more bigger projects that require a greater number of skills. And just to give you an example about where workers are going and when they are actually adopting new skills, you can see Adobe Workshop is one of the highest exposure skill, and this is pre-GPT. And then after ChatGPT, you see these 4 types of skill transition paths. In addition to persistence, right, staying in the same skill, you are also seeing some upskilling, some movement to creative skills, and some movements to soft skills, right, for marketing, for business skills. At the aggregate level, if you look at the workers overall, you see some corresponding evidence, right? The workers are not running away from automation, they cannot. They are moving to related skills, but there's not systematic AI upskilling, okay? We don't see a lot of workers actually moving to AI skills, right? This is flow data. We're looking at the transitions from one skill to another skill. But on the other hand, they are adopting more interactive skills. And that actually pays off. So
in the interest of time, can I ask you to slowly start wrapping up? Thank you.
Sure. Thank you for the reminder. So just to wrap up, we are seeing that the return from this reskilling, and the reskilling seems to pay off, especially if you're doing AI specific skill additions. And finally, this is just to show you for the market as a whole, we see this increasing concentration of work and earnings, especially for the workers that are able to upskill. Thank you, and I'll stop right here. Thanks.
Thank you. Thank you to all 3 of you for a series of very, very interesting papers, both showing new evidence, but also kind of thinking about kind of what this means in the future. We have about 7 minutes left, which gives us time for 1 round of questions. For Chiara, and I'm going to ask each of you a question, but feel free to also address some of the other questions asked to the others. But for Chiara, Heather in the chat asked the question: how much does your proximity to AI knowledge captures the home country activities of your M&E? That is the location of the headquarters. I could imagine that the headquarters needs to be on board before anything will diffuse to subsidiaries in other countries. And your boss example perfectly captured this. Eduard, we received kind of in advance several questions about organizational changes. So Jerwin Pernido from the Philippines asked, when adopting AI at scale, what organizational changes, processes, roles, incentives matter most? And how do you balance innovation with ethics? And Mariella Agorilla from the US asked, for SMEs, what are effective ways to integrate AI into workflows and build a culture of mindful and responsible use? And then for you, Maggie, in the light of your finding of kind of fewer tasks but higher value, Dixon Kawunda from Zambia asks, as AI is reshaping work processes, how can firms use human capital effectively and also address declining confidence or anxiety among employees? So I think we'll have time for one round of questions. So over to you, Chiara.
Thank you, Elwyn. And in the interest of time, I will reply quickly and be honest about the fact that we haven't really tested the exact question that Heather is asking, but we have looked at two, at least for the first part of the question. So basically, Heather is asking whether there is a home bias that we are not controlling for relative to the sort of importance of knowledge. We have not looked directly at this. We have looked indirectly at this in the sense that we do not see a particular sort of advantage of first adopting in the headquarters. We see this in about 40% of the cases. But this is a very good question, and we should check this more directly. Now, what we do find, and this is, I think, the question that is also part of Heather's point, which is how much is the decision of diffusing centralized or not. And here the question is slightly more nuanced, because we do not find that being in the same country as the headquarter matters for diffusion, but we see some elements that suggest centralization of this process, because we do find that, for example, plants that use the same vendor as the first adopters actually tend to be the one where we see a rollout of AI diffusion. And this is very much in line with processes of piloting, which, I mean, we find in other cases. I'm looking, for example, at M&Es in the automation sector in Mexico, and this is part of the way they pilot things using the same type of providers across the whole group. So I hope this answers at least partly Heather's question. If not, she should feel free to get in touch and we can discuss bilaterally. So thank you.
Thanks, Eduard.
All right, thank you so much for the questions. In terms of AI's effects, I heard like, okay, what are the effects on incentives, on ethics? These are all very good questions. The way I'm proceeding, and me and my co-authors are proceeding, is sort of one question at a time, one paper at a time. The papers I've presented don't have much to say really about incentives or ethics. The first two are more about, okay, we have these theories that are not about ethics or incentives, are about structure, how organizations structure the way they work in a way to preserve and you make the best possible use of the expert's time. Okay, and there's whole theories built on that idea, exploring that idea, and it turns out to be very powerful. So what we do is to say, okay, you introduce AI, what happens to this structure, and who is complemented, who is substituted within this framework? Okay, that's what I've tried to understand. But there's many other very good questions about, okay, incentives to, if I think in the organization AI is going to be trained based on my actions, do I have incentives to do what's right? Like, there's all these interesting questions also touching ethical issues. That's one. And in terms of the question about SMEs, what's the situation for adoption for SMEs? I think it's a great opportunity, to be honest, because all of a sudden we all have access to this amazing knowledge out there, right? So before there were a lot of companies that didn't have the budgets to have all this intelligence that are available, and now we all have a lot of intelligence available. So I think the opportunity is great, especially for those who don't have a lot of resources to actually step up and compete and innovate, just like the top companies. Hopefully that's optimistic. I'm not really sure what's happening and the extent to which they face barriers, but I think in principle this should be a great opportunity.
Thanks, Eduard. Maggie, final words for you.
Yes, thank you. Thanks for the question about worker responses. And I think this is actually the part of the research I find I'm particularly intrigued or excited about, because we see very diverse responses among workers. Some people stay put, and some people actively adapt, and by reskilling, some people by becoming broader, adopting communication skills and so on. And some people try to move up to upskill. And we find it's better than doing nothing. If you sit still, you're gonna just, be the one that absorbs the impact. But if you are able to move in any of these directions by adopting soft skills, by moving up, by adopting AI skills, you will, get some returns from that kind of effort. And I think this is a key message that has emerged from our worker level analysis. We are trying to look at this at a more granular level, and hopefully we're gonna document some more interesting, more nuanced patterns of transitions.
Thanks, Maggie. So let me take this opportunity to thank Chiara, Eduard, and Maggie for your presentations and insights. Also, thanks everyone for your questions. As far as I could tell, they were all asked by humans. The AI bots that connected were silent. So we're now moving on to the panel discussion on the future of firms. Sam, over to you.